Stop looking at the road. Stop staring at the Cybertruck. You think you're watching a car company at work? You're hallucinating. What if I told you the vehicles rolling off the line today are just Trojan horses? Decoys designed to distract you while the real weapon is assembled in the dark. You see the metal, you miss the monster. It's late, 2025. The legacy giants are bleeding billions, desperately trying to copy the Tesla of yesterday. They're tracing blueprints for an engine that doesn't matter anymore. Because while they were fighting for market share, Elon Musk wasn't just building a better car. He was building a machine to end the concept of a car company entirely. We aren't talking about transportation anymore. We are talking about the total rewiring of reality. Labor energy, the very physics of how things are made. 5 hidden technologies, 5 keys to a kingdom the competition can't even see yet. This isn't an update. This is an extinction event for the old guard. You want to survive the shift. You need to understand the blueprint. Hit that like button and smash subscribe to DVEXA right now, because the future isn't coming. It's already breathing down your neck. Let's open the box. The playbook has 5 moves, each one a checkmate. First, the unboxed process tearing down the century-old assembly line. Second, 48 Fab T architecture, a nervous system reboot. Third, the 4680 cell, the key to mass market mastery. Fourth, end-to-end AI, the brain that finally unlocks the robo-taxi. And fifth, Optimus, the humanoid that takes that intelligence and learns to walk. Alone, they disrupt. Together, they dominate. A fortress built to secure an insurmountable lead. Today, we deconstruct the stack. How it works, why it matters, and how this convergence changes everything. Hit that like button if you're ready. Welcome to DVEXA. You need to understand the deadliest weapon in Tesla's arsenal isn't a car, it's the factory. You've heard the mantra, the machine that builds the machine. But with the next G platform, that vision stops being a soundbite and starts being a reality. They call it unboxed. For 100 years, Henry Ford's shadow ruled the floor. The linear line, the body in white, creeping down a single track. A swarm of robots and humans performing a cramped, clumsy dance, adding parts one by one. But that rhythm is broken. Think about it. The whole line is shackled to its slowest step, a total bottleneck. Workers fighting for space diving inside the frame, wrestling with wires. It's inflexible. Retooling is a nightmare. It's slow, it's heavy, and frankly, it's obsolete. So Tesla's unboxed method throws that entire 100-year-old concept in the trash. Instead of one long, slow line, the factory is organized into parallel processed chunks. Think of it like building a Lego car. You'd never build the frame first and then try to stuff the little driver through the tiny window. It's absurd. You'd build the floor. You'd build the front block, the rear block, the cabin, and then at the very end, you just click them all together. This is exactly what the unboxed process does. Imagine this. Over in one corner of the factory, that massive front gigacasting is getting its motor, its suspension, its steering. At the exact same time, in another corner, the rear gigacasting is getting its motor. And simultaneously, the central floor pan, which is the 4680 structural battery pack, is being prepped. The real magic open access. Workers and robots have a full 360 degrees attack. You want to install a dashboard. It's simple. There's no roof. There are no doors in the way. It is massively faster. It's more ergonomic. Then and only then do these huge pre-assembled, pre-ested modules meet. The front, the rear, the painted side sections, they're all joined to that structural pack in one final step. The results. Tesla claims a staggering 40% reduction in factory footprint, a 25 to 30% increase in production speed, all while slashing the cost to build the factory in the first place. This isn't just an improvement, it's a new paradigm. And if you want to follow this revolution, you need to be subscribed to DEXA. This is the only way Tesla can realistically build that $25,000 car at high volume, and most importantly, at high margin. But here's the secret. That unboxed method, that whole Lego block strategy is only possible because of another Tesla innovation, gigacasting. You have to understand, traditionally, a car's underbody is a complex puzzle. We're talking 7,100 even more different stamped metal pieces. All of them have to be painstakingly welded together by a massive body shop of hundreds and hundreds of robots. Tesla's Gigapress, a machine the size of a small building, throws all that out. It casts the entire front or rear underbody as a single piece of aluminum. Just that one innovation, it eliminates over 300 robots. It erases 600 plus welds. It frees up a massive amount of factory space. The resulting part is stronger, it's lighter, and it is critically, unbelievably faster and cheaper to make. That single gigapart that is the Lego block that the unboxed method is built on. And this is the part that should make you hit that like button. While competitors are just now scrambling to order their first gigapresses, they're already years behind because Tesla isn't just ahead in the machine. It has a multi-year lead in the metallurgy, the secret sauce. That special aluminum alloy that is strong, not brittle, and perfectly castable at high speed. That is a deep, costly moat. And for legacy automakers with their billion-dollar investments in those old-world body shops, crossing it might be impossible. So you have the unboxed skeleton. Now you need a nervous system. And for over 60 years, the entire auto industry has been locked into a dying standard, a 12-volt system. You have to understand this. 12-volt standard was designed for simple machines, a car with lights, a radio, and maybe power windows. But today, your car is a supercompute on wheels. And that 12-volt system, it's become a critical bottleneck. The problem is just basic physics. You've heard the equation. Power equals voltage time current. If you want more power, say for faster moving seats, a more powerful audio system, or the advanced steer-by-wire. You see, in the Cybertruck, you have to raise either the voltage or the current. And since the industry has been stuck at 12 volts, their only option was to drastically increase the current. The result, thick, heavy, expensive copper wires to manage the heat and the load. We're talking about a wiring harness in a modern luxury car that can weigh over 50 kilograms. That's over 110 pounds. It's miles of copper. It's one of the most complex, costly, and manually installed parts in the entire vehicle. Worse, you hit a hard limit. You simply cannot run the high power systems of the future on a 12 VT rail. Not efficiently, not safely. So what does Tesla do? They changed the equation by moving to a 48 VT system, first in the Cybertruck and now standard on their next G platform. They flipped the table. Think about it. To get the exact same amount of power, if you multiply the voltage by 4, you can divide the current by 4. That is a profound change. A 4 times reduction in current means you can use wires that are dramatically thinner, dramatically lighter, and dramatically cheaper. And the power you lose is heat that drops by a factor of 16. The Cybertruck's wiring harness is a fraction of the size of a normal truck's. This saves money. This reduces weight, which increases range, and it massively simplifies that unboxed manufacturing process we just talked about. It's the key that unlocks the Ethernet data bus, where a single cable can finally carry both power and data, destroying the one wire per function nightmare of the past. But this is the part that should have every legacy automaker terrified, and it's why you need to click that subscribe button for DEXA. This shift to 48 volts, it's not just an internal change. It is a shockwave to the entire global supply chain. For decades, companies like Bosch Continental and Denso have perfected the 12-volt world. All those window motors, the pumps, the fans, they are all 12 volts. By moving to 48 volts, Tesla is effectively making its entire parts list obsolete. Suppliers now have to re-engineer, retool, and revalidate everything. A company like Ford or GM, they can't just switch. They are being held hostage by a supply chain that simply isn't ready. But Tesla, because they designed so many of their own controllers, their own components, they can force the change. Their vertical integration lets them absorb the complexity. While their competitors, they're left tethered to a 60-year-old standard, adding yet another layer to Tesla's massive manufacturing and cost advantage. So your factory is fast. Your car's nervous system is efficient, but you still have a massive problem: energy. The car still needs a breakthrough to be affordable for everyone, and that breakthrough is the 4680 battery cell. The name, it's just the dimensions: 46 millimeters wide, 80 millimeters tall. But it's design that is the revolution. You see, a traditional battery like the 2170 cells in a Model 3 has two little tiny tabs at the ends. All the energy has to fight its way in and out through these two tiny bottlenecks. This creates a traffic jam. It creates massive heat, especially when you're charging fast or flooring it. The 4680S tabless design is pure genius. Instead of a tiny tab, it uses a shingled spiral. This means the entire edge of the battery's internal foil is the connection. The path for the energy is suddenly short, wide, and clear. This one change fundamentally rewrites the cell's properties. First, less heat, drastically less. Second, faster charging. With no heat to manage, you can flood the cell with power. And third, more power instantly. This is the secret to Plaid-level acceleration. But that isn't even the real story. If you're enjoying this deep dive, hit that like button for DEXA, because the manufacturing is the true change everything moment. It's a process called dry battery electrode, or DBE. For 50 years, everyone has made batteries the same way: a wet slurry. You mix the battery materials into a toxic wet paste. You paint it onto a foil, and then you run it through massive 100 meters long energy blasting ovens to dry it out. Tesla's DBE process: it stamps the active material dried directly onto the foil. No solvent, no water, no drying. Now, you need to understand how impossibly difficult this is. It is the holy grail of battery manufacturing. It's the main reason the 4680 ramp-up was so slow. The old wet method is like painting a wall. It's slow, but the paint spreads evenly. The dry method is like trying to spread a layer of fine dust perfectly evenly on a wall, make it stick, and do it at lightning speed. It's like trying to compress fine gravel into a perfect mirror. And as of 2025, Giga Texas is finally scaling it. This process, it doesn't just promise to cut factory footprint and energy use by 10 times. Internal reports are already clear. The 4680 cell is already cheaper for Tesla to make than anything they can buy from suppliers. This is the final piece of the puzzle. You combine this cheap, powerful cell with a structural pack where the battery is the floor of the car, saving 370 parts, and you have the key. This is the only way the $25,000 car is possible. It's the only way the Tesla Semi works. So the 4680 cell is the heart. But now we talk about the brain, full self-driving. For years, FSD has been this promising, controversial, coming soon beta. But with version 12, it went through a change as fundamental as the jump from a flip phone to a smartphone. You see, the old way, FSD 1 and everything before, it was a mountain of code. It was a complex, human-written stack, hundreds of thousands of lines of C++, a giant, fragile rulebook. If the camera sees a red light, and then apply the brake. If a car is merging, then calculate its trajectory. If it's a stop sign but there's a pedestrian and the cross traffic is clear. This approach is brittle. It's impossible for a human to write a rule for every edge case the real world can throw at you. A stop sign hidden by a tree, a construction worker waving you through a red light. This is why true self-driving has been almost solved for a decade. So with FSD V12, Tesla did the unthinkable. They deleted it. They deleted over 300,000 lines of that C++ code, and they replaced it with a single end-to-end neural network. This new system was not programmed, it was trained. Tesla fed it millions of video clips of its best human drivers and essentially told the AI, "Watch this, learn to drive like this," and it did. Now the system takes in raw video from the cameras and outputs steering acceleration and braking commands. Photons and controls out. This is the ChatGPT moment for physical AI. The AI is predicting the next most likely driving action based on all the video it has ever seen. It learned how to creep at an unprotected left turn by observing humans do it, not by reading a rule. And this system is infinitely scalable. To make it smarter, you don't hire 1,000 engineers to write more if then rules. You just curate new tricky video scenarios, add them to the training set, and recompile the brain. But an AI is only as good as the data it's fed and the computer that feeds it. First, the data. With over 6 million FSD-capable cars on the road, Tesla has the largest data gathering operation in history. When a driver takes over, the system flags that video clip, that difficult snowy left turn, and uploads it to the data factory. Second, the computer. You've probably heard of Dojo Tesla's custom supercompute, but here's the Dervexa level update. Because as of late 2025, the game has already changed. Tesla realized that having one giant separate computer for training Dojo and a different chip in the car for driving was inefficient. It was a bottleneck. So they're pivoting. They are now focused on a unified AI architecture. New chips called AI5 and AI6 that will do both. They are building their new training supercompute, what you could call Dojo 3, out of the same powerful chips that will be in their future cars. This creates the ultimate flywheel, a doom loop for competitors. Better AI leads to a better FSD. More people use it. More data is collected, the AI gets better faster. And their new unified computer spins this flywheel at a speed and a cost no one else can match. This is the only path that plausibly solves full autonomy. And when it does, it unlocks the single most disruptive economic force of all, the robo-taxi. A $25,000 car that can drive itself 24/7 and earn $30,000 a year. That isn't a car anymore. It's an asset, and it's one that will change our cities and our world forever. If you want to see that future happen, make sure you're subscribed to Droxa. So what do you do with the world's most advanced real-world AI and intelligence trained on billions of miles, running on custom silicon, powered by the densest batteries on the planet? You don't just leave it in a car, you put it on legs. This is Optimus. You have to understand, this isn't a side project. It isn't a gimmick. It is the logical conclusion of every technology we've discussed combined. Think about it. The brain Optimus runs the exact same neural net as the fleet. The AI that learned to survive a chaotic street can easily master the factory beat. It just swaps car physics for human physics. Walking, balancing, grasping. The power it runs on the 4680 architecture. The manufacturing it's built with the same unboxed, Geiger-casted principles. And the progress is staggering. Gen 1 could barely stand. But Gen 2.5, it has hands so tactile, so precise, they can handle an egg without breaking the shell. And this isn't a simulation. These bots are in the factory right now, taking the jobs that are boring, unsafe, or repetitive. But that's just the start. You might ask, why a complex humanoid? Why not just put it on wheels? The answer reveals the true scale of the ambition. Because the world isn't built for wheels, it's built for us. Our stairs, our doors, our tools. They're designed for 2 legs, 2 arms, and 5 fingers. A specialized robot is stuck in one place. But a humanoid like Optimus It can work in any space. It can install a door today, stack boxes tonight, and go home to wash your dishes by the morning light. You don't redesign the world for the bot. The bot fits into the world you've got. This isn't just a new product. It is an entirely new programmable labor force with a potential demand of 20 billion units. This is an economic shift, larger than the car, the PC, and the internet combined. If you want to stay ahead of this future, you need to be subscribed to Droxa, because when you zoom out, you see the truth. Tesla's tech isn't a list of parts, it is a single vertical art. The Gigacast factory builds the cheaper car. The car is the vessel for the 4,680 star. The battery powers the FSD brain. And that brain's final form isn't a vehicle at all. It's the mind of Optimus. You see, each piece is a lock, and the next piece is the key. They aren't just selling you an EV, they are building the manufacturing, the energy, and the AI infrastructure to power a new industrial reality. Whether this colossal gamble succeeds and whether we are ready for the shock is the multi-trillion-dollar question of our time. Thank you for watching Droxa. If this deep dive blew your mind, hit that like button and subscribe with notifications on so you never miss the shift.